Hi guys and welcome to this video. Kleena here, and today I'm going to be taking you through the solution to question 11 from this Junior Cert Ordinary Level paper, and this question is based mainly on trigonometry, so let's get started. So we're told that two friends are building a skateboard ramp and they each have a different design for the ramp. So in question A we're talking about Tracy's design. We're told that Tracy draws the following diagram as part of her design for the ramp. It's made up of a triangle and a square, and it is to a scale of 1:100. So the angle A is marked and we can see A there, and we can see the measurements. So we can see that the bottom of the triangle is 3.5 centimeters and then it's attached to a square. So now let's go on to A part 1. We're asked to construct a scale diagram of this part of the design for the ramp in the grid below to a scale of 1:50. Each side in your diagram should be twice the length of the corresponding side in Tracy's diagram. So one side is already done for you. So if we go up to the diagram here, we are told that it's drawn to a scale of 1:100. So the one that we're asked to draw is going to be twice the size of the 1:100 scale. So if that doesn't make too much sense to you, what you can look at is, because one side is done for you, this should be here. We can see it's 2 centimeters, but then here it's 4 centimeters. So here, this 2 centimeters needs to turn into a 4 centimeter one in our diagram. And this 3.5 centimeters needs to double, just like the other ones did, to 7 centimeters. So let's have a look at what we can do. So here we can see that they've used a box as a centimeter. So this is 4 centimeters here. So we're going to go across another 4 centimeters for the square. So we have 1, 2, 3, 4. Okay, so that's going to be our square, like so. And I'm going to use my ruler to draw it in a minute. And then I'm just going to change pen color. The side of the bottom of the triangle that was 3.5 centimeters, we're now going to double that, and it's going to be 7 centimeters. So here we go, 1 centimeter, 2, 3, 4, 5, 6, 7 centimeters. And then we're going to go draw a straight line from here to here, again using our ruler. And there needs to be a dotted line up here as well to separate the square and the triangle. So now I'm going to get my ruler and I'm going to do this. So I'm going to draw the line straight along the bottom first. And now I'm going to draw my diagonal line, which is the skateboard ramp. And then I'm going to draw the top of the square up here. And finally, I'm just going to draw a line that separates the square from the ramp or the triangle. So now the final thing to do here, I'm just going to write in the measurements. So we have 4 centimeters there. So this is also going to be 4 centimeters from here to here. This here is going to be 7 centimeters. Okay, I'm going to draw an A here, this angle A. And this is 4 centimeters here. And the top is also 4 centimeters. So this is our scale diagram done. And for this, you're going to get a total of 10 marks. So now let's move on to question A part 2. So in question A part 2, you're going to need to use your protractor. It asks us to measure the size of the angle A in Tracy's diagram above. So if we go up to Tracy's diagram, you're going to want to measure this angle here using a protractor. So I can't use one now, but what you're going to want to do is place your protractor like so that the middle point is here. Sorry, it's a bit off center in my one here. So you'll have your 0 degrees here. And then it'll go up along here, so it'll be 10, 20 degrees. And this line here, measure what this line says. And it should say 30 degrees, okay? So that's our answer for this. So this angle A is 30 degrees. And for this question, you're going to get a total of 5 marks. Now let's go on to question B. Now in question B, we're talking about Sinead's design for the ramp. We're told that part of Sinead's design is the right angled triangle in the diagram below, and we're told it's not to scale. One of the sides is marked B and one of the angles is marked C, and we can see that in the diagram. We are asked to use the theorem of Pythagoras to work out the length of the side B in Sinead's design, and we're asked to give our answer in centimeters. So, what is the theorem of Pythagoras? So when we are given a right-angled triangle, what we can do is, this is the hypotenuse. And what we're going to do is, the hypotenuse squared is going to be equal to the other angle. Let's call this A and let's call this B. So the length A squared plus the length B squared. So what do we have here? The hypotenuse is B. We don't know what B is. A in this instance is 180 centimeters and B in this instance is 96 centimeters. And I hope you can see that I'm getting these from the diagram up here. Okay, so B is the hypotenuse because it's across from the right angle. So the hypotenuse squared is B squared, and that's equal to A squared, which is 180 squared, plus B squared, which is 96 squared. So now let's use our calculator to find out what 180 squared plus 96 squared is. And that gives us 41,616. So B squared is equal to 41,616. Now, we have B squared, but that's not what we're looking for. We're looking for B on its own. So how are we going to get rid of this square here? We're going to find the square root of both sides. So the square root of B squared is going to be just B on its own. And that's equal to the square root of 41,616. So B is equal to, and we're going to use our calculator here, the square root of 41,616. And that is equal to 204. And that is in centimeters. So our answer here is B is equal to 204 centimeters. And for this question, for getting the correct answer, you're going to get a total of 5 marks. So now we're done question B, we're going to move on to the final part of this question, question C. So in question C, we're told that Sinead knows that for the angle C, the tan of C is equal to 96 over 180. We're asked to use our calculator to find the size of angle C, correct to the nearest degree. So we did something to get rid of the squared. Okay, so here we need to do something to get rid of the tan and let C on its own. So what we can do in this instance is we need to find the inverse, the tan inverse. Okay, so we have tan of C is equal to 96 over 180. We want C in its own, so what we do is we put tan to the other side, but it's not just tan when you move to the other side, it's tan inverse, and there's a button for this in the calculator. So tan inverse, this is what it looks like, of 96 over 180, and this is going to give us the size of the angle C. Now let's do it on our calculators. So we can see this is the tan button here, that's not what we want. Do you see above the tan button, there's a yellow sign, that's the tan inverse. So to get this little yellow one, press shift, and you can see that shift is in yellow. Then press tan, and there you go, tan inverse of 96 over 180. And that gives us 28 degrees, and it's 28 to the nearest degree. So C is equal to 28 degrees, and this is our final answer. And for this answer, you're going to get 5 marks. Right guys, so that's all for this video. I hope you found this very helpful and that it might have cleared up anything that you were confused about. Thank you all very much for watching, and I'll see you in the next video.